So I welcome you all again in the session 2 of this 6-day online STTP. We welcome our expert of this session, Dr. Kumar Sahoo.
Good
Let me
morning.
take
Good
the
morning.
privilege first to introduce Dr. Sahoo with you all. Dr. Prafulla is an assistant professor in the Department of Environmental Science and Technology of Central University of Punjab, Bathinda. Prior to this, he was working as an adjunct researcher in the Hydrogeology Research Group of Whale Institute of Technology, Belém, Brazil. He has received his PhD in 2011 from the Indian Institute of Technology, Kharagpur. After that, he joined as postdoctoral fellow in January 2011 to September 2012 in Hunsan National University, Korea. He is recipient of BK21 postdoctoral fellowship from South Korea. He has been selected as a Young Scientist Fellow in Brazilian Academy of Science. He has received Research Excellence Award from IIR-SG Netherlands. He is currently serving as an editorial member of Current Pollution Report, Springer, and Soil Pollution and Remediation as review editor for Frontiers in Soil Science, and also serving as reviewer in several peer-reviewed journals like Journals of Hazardous Materials, Applied Geochemistry, Science of Total Environment, Journal of Geochemical Exploration, etc. During his research career so far, he has co-authored 54 papers in Scopus Index journals and 3 elsewhere book chapters. His H index is 17. He has more than 1056 citations in Google Scholar and 690 citation in Scopus. His primary research is related to understand the fate and transport of contaminants in water, that is in surface and subsurface water, soils and sediment system, prediction, remediation and prevention of surface and subsurface water contamination caused by mining and other anthropogenic activities and plant-soil interactions. We welcome you, sir, in this session 2 of day 6 of this 6-day online STTP. Now, I would like to request Dr. Sahoo to start with his lecture on geogenic groundwater pollution in India, sources, processes, and major challenges.
Thank you. Thank you so much, madam, for your kind words. First of all, good morning to all. At the outset, I would like to thank Professor Manjit Bansal, Program Coordinator, and Dr. Sukhdeep Singh for your kind invitation and giving me this such an exciting opportunity to deliver a talk in your esteemed 6-day online STTP, that is on short-term training program. And also this training program is focused on one of the major challenges, that is climate change and water security. Well, water security is one of the most challenging and crucial environmental issues these days. And I hope through this STP, all the participants, they have got a lot of insights, lot of ideas, lot of inputs on various dimensions of climate change and water security. And they have also studied about water pollution. So in water pollution or water contamination, one of the major aspects is geogenic contamination of groundwater, which is very severe. It's not only problem in India, also it's a global problem. So this is the topic I will cover today. And in my lecture, I specifically cover groundwater distribution and issues in India, some of those issues. And also I'll briefly discuss about what are those types of contaminants, what are contaminants. Then I will discuss about what are those anthropogenic contaminants, and I will emphasize on geogenic contaminants. Then another important part, I have to also briefly describe what are those origin and process of those geogenic contaminants. That is very, very important. Then since we are talking about geogenic contaminants, we have to also understand the hydrogeological setup of India, which is very important because that is lead to this geogenic contamination. Then I will talk about geogenic contamination issues in India, all those arsenic contamination, fluoride, then uranium, this contamination. I will discuss how this situation in India, the process and the origin. And also I will discuss at the end some of the challenges and conclusions. Well, as we know, this groundwater is nothing but the water occurring below the earth surface. That is occurring the zone of saturation. So if you can see the distribution of water on earth's surface, that is almost 3/4, about 70% of the earth's surface that is covered with the water. That is called hydrosphere. And in this hydrosphere, about 96.5% of all water that resides in ocean and seas in the form of saline water, while the remaining 2.5% that is fresh water. But of the total fresh water, if you can see, 68.7% of water that mainly resides or trapped in glaciers and ice cap, which is not available. But then when you talk about this groundwater, the contribution is 30.1% of groundwater that is exist in the subsurface. But when you talk about available fresh water, so this is the total. When you talk about the available fresh water, so these groundwater that generally contribute about 95% of the available fresh water. Therefore, this groundwater is the main source of fresh water and the major source of drinking water. So in India, if we see the Indian perspective, so in groundwater is the most preferred source of various sectors, that starting from these in the rural sector, almost 85% dependent on groundwater. Then urban sector, that is almost 50%. Then when you talk about this irrigation, almost 84% is coming from groundwater. And also when you talk about the country's GDP, this groundwater contribution is almost 9%. And also, if you talk about total drinking water in India, that 90% is coming from groundwater. So now if you can see here, India, that is represent 18% of the world's population. But the India, it has only 4% of the world's water resources. So now it is estimated that the country would need 1,180 billion cubic meter of water annually by 2050. But if you can see the projection of water, the available, that is average annual potential of utilizable groundwater, that is total water, that is 1,123. And out of this, surface water is 690 billion cubic meter, then groundwater is 430 billion cubic meter. And these 430 billion cubic meter, that is the annual replenishable groundwater resources. And out of these, if you can see, out of this 433, so majorly used in the irrigation purpose, that is 222. Then domestic purpose is 223. That is total 245 billion cubic meter of groundwater annually extracted for this purpose. And irrigation is the most dominating sector this groundwater is used. And if you can see, these are the states, Punjab, Haryana, West Bengal, so they are plentifully extracting this water for irrigation purpose. But in the domestic, the proportion is quite low. So if you can see this way, if the groundwater will be used, how this will affect to the hydrological system and how it will affect to our groundwater resources. So according to this report, Central Groundwater Board, so what they have studied, the daily per capita available of groundwater in liter. If you can see, if it is 1951 per capita was 14,180, but in 2001 that has been drastically reduced to 5,120. And again, it is expected that 2050 our annual available per capita availability will be 3,120. That you can see how this groundwater availability is drastically declining. So if you can see the global perspective, India tops the list of the top 10 groundwater abstractive countries and the largest user of groundwater. Okay, that will be around 245 billion cubic meter. That is almost 25% of the global withdrawal. And if you can see this much, that can, if you can see the calculation, that exceeds the groundwater extraction of the US and China combined. So if this figure, from this figure, Central Groundwater Board, they have studied and they have given a warrant that there will be a reduction of another 22 to 35% by 2050 if we will going this way, and if we cannot think of our groundwater resource or the management of this resource, and we will go for exploitation of this groundwater excessively. So now if you can see, this is the groundwater scenario in India. This is the annual groundwater extraction. If you can see, mostly this groundwater in the Indo-Gangetic basin, that is in the state of Punjab, Haryana, Uttar Pradesh, they are mainly hugely extracting this water, and mostly, as we know, this belt is mostly agro-intensive belt. Most of this agricultural activities going on. So if you can see the general statistic about how much groundwater is recharged and how much is precipitation, if you can see that annual precipitation is 4,000 billion cubic meter. But if you can see for the groundwater, that is annual replenishable, that means this much is recharged, only 433 out of 4,000. That means groundwater recharge is accounts only 10.8% of the total annual precipitation India receives. But if you can see, the groundwater use is huge. Irrigation is the most dominating sector. So if this planned, if these things will be continued along with a lot of unplanned urbanization, or overpopulation, overuse, that will drastically affect to our groundwater resources. So if you can see, this is the groundwater scenario in India, that groundwater level, if you can see, various parts of India are declining as the country couldn't afford adequate research aquifer in the deficit area. If you can see, this is the CGWB report, that is 56% of the waters are declining. And according to another report, that is 2017, that is almost 60.7% of wells, their groundwater level is decreasing. And if you can see percentage of wells that is below the water table, if you can see dominating like Tamil Nadu, Punjab, Andhra Pradesh, lot of states, their wells groundwater table is declining. And if you can see here, that is another study, that is CGW. They have studied all over India, and they have taken almost 10,219 wells, and they have found 5,690 wells there. They have drastically serious situation. And also, if you can see the stage of groundwater development, this is very important. If you can see, this is currently we are in the 62%. But if you can see, certain states, they are like Punjab, Rajasthan, Delhi, Haryana, they are exceeding 100. Exceeding 100 means if the stage of groundwater development is exceeding 100, that means annual groundwater consumption is more than that the annual water recharge. So these are the countries, Punjab, Haryana, Delhi, and these are the countries mostly extracting huge groundwater for the irrigation purpose. So this is another one. If you can see the pre-monsoon, post-monsoon comparison, the water table, if you can see the both pre-monsoon and post-monsoon, we have this water table is drastically, there is a means declining. And most of the area which is falling trade, if you can see the state of Rajasthan, Punjab, Haryana, Delhi. So these are the states mostly agri-intensive region who are mainly doing this agricultural activity, and they are extracting a lot of groundwater. So what you can see, India is, as we know, this is almost this northern and western part of India is looming. That means there is a serious problem with water. Along with it, there is water scarcity. We have also water excess, because as we know, in India, a lot of flood events are happening, and those excess water, that is also another challenge for India. So whatever the water scarcity and water excess like flood, but at the end of the day, we have to have drinking water security, which is looming today. This is due to contamination. So now if you can see this water contamination, according to this Niti Aayog observation, we have almost 70% of water is contaminated in India. But if you can see, 33% of water is undrinkable. This is the most important concern. That means groundwater in 33% of India is undrinkable due to presence of toxic chemicals like this fluoride, arsenic, uranium. Then we have this salinity problem. You can see this is another report. This Times of India. If you can see a lot of nitrate, fluoride. These are the major worrying situation that India is facing. So now, since we have a lot of discussed about this contamination pollution, let's first discuss about what is the difference between this pollution and contamination. Are they same or different? Although in scientifically, these two terms are means synonymously used, but let's see what is the difference between these two terms. So generally, when you talk about pollutant and contaminant is something that doesn't necessarily cause adverse effects. But when you talk about pollutant, it generally causes adverse effect to any living body. So generally, if you can think about, let's one example. Suppose if you are drinking tea, if your tea is contaminated with fruit juice, so that is contaminated. Although it has been changed, it has been that has been altered, but that necessarily cause any adverse effects. But suppose if you are drinking tea and you will have some poisonous substance in your tea, that is called pollutant. That is polluted. That means that will cause adverse effect to in any living body. So that means if you can talk about this in a generalized way, all pollutants can be contaminants, but not all contaminants can be pollutants. And if you can see the comparison, already we have discussed, contaminant doesn't necessarily cause harm, but pollution often leads to damage. And one important aspect, pollution is mostly caused by this anthropogenic activity by this human. But contaminant doesn't necessarily by human. And when you talk about this monitoring, regulation, all those things, they are government body, they're mostly focused about this pollution. Mostly government that monitoring regulation, that is basically on the pollution. So that is less focused on the monitoring regulation by the contamination aspect. Although these two terms have some meaning, but they are regardless of these things, many scientific communities and even journals, they have used the same meaning of these two terms. Let's another aspect is a very important or interesting as well regarding the difference between pollution and contamination. So generally, contamination, suppose if you have lot of, if you can see a lot of these activities, suppose industries, power generation, agricultural, and they generate a lot of contaminants. So now, if you can see from these contaminants, we'll have this lot of contaminants that get released from these activities. Now, if you can see the red color and another one is the blue color. So here, the blue color is contamination. That means contamination doesn't affect the biochemical and biological process. Although it comes to the environment, comes to the system, it doesn't have any biochemical changes. But the red one, if you can see those heavy metals, they are lead to pollution. They generally affect biochemical and biological process. For example, mercury, that will be methyl mercury. Once it will be get into the system, so what will happen? It will be in the aquatic biota, then small fish, big fish. That means something like bioaccumulation, biomagnification. So that will be the biological, biochemical process will be changed. Biomagnification will be there. So that kind of pollutant that can be lead to pollution, they causes pollution. But contaminants, suppose if this zirconium, then lanthanum, this, even if this system, if it comes to the water, they are less affected or less influenced by this biological and biological process. So now let's talk about, we have already discussed about this pollution, contamination, all those things. So let's discuss what is this water pollution or the water contamination. So according to the definition, water pollution is something, any undesirable or unwanted change in the water quality. That means it leads to deteriorate these physical, chemical, and biological characteristics of water, and that generally harms to the living organisms, and it will be unsuitable for desired use. It's not only for drinking purposes. This water is being used for the livestock purposes, then gardening, then fishing, agriculture, lot of other, then various industrial use. Then water quality is something that will be related whether it is suitable for the particular desired use. And each purpose you will have the different water quality guidelines or the standard that should meet. So therefore, when you talk about this water quality, we will have this physical, chemical, biological characteristics. Suppose in the physical characteristics, we will have this pH, EC, electrolytic turbidity, then we have temperature, then we have chemical characteristics, we have all those heavy metals, then we have this cations, anion, fluorides, other contaminants, salts. Then the biological contaminants will have this will these chlorophyll, cyanobacteria, then virus, E. coli, lot of other contaminants are there. So generally, it's very important to understand this water quality with respect to all these physical, chemical, and biological aspects. Then only we can rely on our water and we can understand how it will be important for the water quality. And that information is really important for our protection of our water resources. So now we have discussed about this water pollution. Now let's talk about what are those types of water pollutants. If you can talk in general, so generally if you can think about surface water or groundwater, so that can be contaminated by both man-made and natural pathways. Suppose in anthropogenic activity, if you can see a lot of activities here. So by doing this activity, they will generate, for example, these sources like solid waste from the point source. Then we have landfill, septic tank. Then we have agricultural activity. Then we have fertilizer application, lot of other industrial waste, industrial drainage. So they generally generate a lot of these contaminants, and this is referred to the anthropogenic contamination in general. But when you talk about types of contaminant in specific, among these anthropogenic, we have a lot of other contaminants like organic contaminants. So what are those organic contaminants? Organic contaminants can be two different ways. One is that is oxygen, that is degradable organic compound like this organic waste or something like that, carbon based, those things. That's manures and those can be degraded in the atmosphere. But other organic, those are really very important and we should be concerned about these. Those are synthetic organic compound like pesticides, DDT, chlorinated compound, all those that has been introduced in the water system through various agricultural and industrial and other kind of activities. Then we can see this is one, it's very important, radiological contaminants. What is that? Radiological, mainly the radioactive contaminants through this like uranium, radon, then we have thorium, all these radioactive contaminants. So if you can see these radioactive contaminants, although it can be geogenic, like through the extraction of uranium ore, something like that, it can comes from these geogenic activities. Also, these radiogenic contaminant, it comes from various anthropogenic activities. For example, it has been used in the various research purpose, in the medical purposes, and even it has been used for the resource, and also in the other anthropogenic activity, like in the fertilizer application, we have in the phosphate fertilizer also contain uranium, other things. So this way that radiogenic contaminants come into this environment. Then we have inorganic contaminants. This one is very, very important because when you talk about inorganic, so it includes the contaminants like mineral acids, inorganic salts, nutrients, metals, cyanides, sulfates. Then we have these heavy metals, all those things. And along inside these geogenic contaminants, our group that will be geogenic contaminant will be called, that will become inside inorganic contaminant, that we will discuss in the next slides. Then this one is microbiological contaminant. We have already discussed, that is bacteria, virus, protozoa, and other parasites. They generally through this waste and also human waste, municipal waste, and some other waste, they generally comes to environment. And another one is emerging contaminant. This one is very, very important. It's called emerging contaminant, and mostly in the emerging contaminant because it's a emerging environmental concern, which includes pharmaceutical products, microplastics, then we have personal care product, and those are generally coming from the various anthropogenic activities. And remember, this emerging contaminant is very challenging. Why? Because all those inorganic, suppose heavy metals, other heavy metals, we have the regulated body that generally we have this permission limit. We know what is that particular contaminant permission limit, accordingly that can be regulated. But this emerging contaminant, it's very important. They do not have any regulatory limit. They do not have any guidelines. Therefore, even we do not know how much contain if the environment, those this pharmaceutical and microplastic will be there, that will be harmful to human health. Therefore, this one is a very challenging, and lot of research is going on to find out to fate and mobility and their health concern. And in the inorganic contaminant, one aspect we have already discussed, that is heavy metal. that we all know heavy metal, which is the major concern about water quality. So what is heavy metal? Heavy metal is nothing but the metallic element which is relatively high density, that is like 5 gram per cubic centimeter. But the heavy metal different, there are classification of heavy metals. Suppose if we have beneficial, some essential heavy metals, also copper, iron, that can be also helpful for the human health in some limited quantity, and some precious metal like gold, gold, copper, also they can use for the ornament and some other purpose. Then the another one is toxic heavy metals. This is very important. So this is also the metallic element. But when you talk about this environmental perspective, this heavy metal is, that is refers to metallic element. They are really toxic at low concentration. This is very important. And these elements, heavy metals, they are poisonous because they bioaccumulate. And most of these heavy metals like mercury, arsenic, cadmium, chromium, then zinc, lead, uranium, these are called heavy metals. And even heavy metals that contains both metal and metalloid, like arsenic, that is also called as a heavy metal, although arsenic is a metalloid. But in the heavy metal group, both metal and metalloid will be included. Then another important term is potentially toxic element. This one is very, these days it's booming up for this PTE. So this is, what does it mean? So generally PTE is a collective term applied to the group of metals and metalloids. If you can see, these are the heavy metals group, including this lighter element like aluminum, then non-metal and metal like arsenic, phosphorus, and selenium. And group of this element, that is called PTE, potentially toxic elements. And when we talk about this environmental sensitive elements or the environmental contamination, all this aspect, the major thing is focus what are the level of PTE. So again, from the heavy metal, we are coming to this geogenic contaminants. Okay, that means all these arsenic, uranium, chromium, these are the geogenic contaminants. Those are also heavy metal, and along with we have one anion, that is fluoride. So these are the geogenic contaminants, which is the major concern, and a lot of things we'll discuss today. So generally, when you think about this geogenic, what does it mean? So geogenic means that is the result of geological process such as weathering of rocks and leaching of minerals. This is very important, and this through this process, this contaminant released to the environment. And also this geogenic contaminant, although it's a geogenic process, anthropogenic factors accelerate this contamination that we'll discuss. So basically what we have seen, this groundwater quality, when you think about groundwater quality, it will be different from surface water quality. It's first important thing we have to note. Because groundwater, what is happening once the rain falls, it get percolates, and the soil generally acts as a buffering media. If you can see, soil and this porous media, they just act as a buffering media. After that, they will leach that water and goes to surface, to subsurface in the aquifer. Okay, therefore the quality of the groundwater is generally believed it's superior to surface water because it's purifying by this soil column. So now if you can see what is the general difference between surface water and groundwater, generally what will be the difference? The surface water is mostly less. If you talk about this microbiological pollutant and the physical pollutant, like physical parameter like turbidity, suspended sediment, all this in that will be very low because the soil act as a buffering media, filter media. Then even the microbiological pollutant are also very less, but those are present highly in surface water but very less in groundwater. Because in the also in, if you can see in the subsurface, mostly the oxygen level in the groundwater is almost nil or very low concentration. But if you see surface water, that will be, it's very high in saturation level. But the major difference, if you can see, groundwater will have higher TDS generally than surface water, because in the subsurface, those water that resides for the longer period, that is the longer, that is water interaction, that is the residence time, is one of the major important factor that leads to more leaching of these aquifer materials, rocks, everything, that leads to increase the TDS, that is total dissolved solid in groundwater. So again, if you talk about the geogenic contaminants, okay, it's most important And that will be, although it's present in surface water, but in groundwater, some of those places are very high. This is the major concern for groundwater security. So now let's discuss about what are those factors that controlling geogenic contaminants. If we can talk about what are those natural factors, anthropogenic factors, let's first talk about the first dominating one is the rock water interaction and weathering. So that means geogenic contaminants of groundwater, they might emanate from geological characteristics of the aquifer material. That is high concentration of contaminant in the rock matrix that get dissolved during the water rock interaction and some environmental condition, and that comes to water. And another important factor is geological condition, types of rock. It's very important because the type of mineral that contain type of type of rock that contain type of minerals, and those minerals are main culprit of those geogenic contaminants. So therefore, those minerals and the associated rock that will depend upon the geological condition. Therefore, these groundwater contamination, it's not uniform. It's haphazard, and it will be specifically depend upon the geological condition in the certain area. Then we'll have this climatic condition as well. Then atmospheric deposition like sea salt erosion and volcanic eruption, also another major factor that control these contaminants. And the process, chemical process, one of the major things. One is origin, another one is process, because in the subsurface, lot of chemical reactions, biogeochemical reactions occurring that generally facilitate that leaching of these contaminants to water bodies. For example, redox condition. For example, that means redox condition in oxidation reduction condition. Suppose if you will be oxidation condition, that means sulfide minerals will be there at subsurface. If the condition will be oxidizing, sulfide minerals get weathered, and sulfide minerals mostly contain these heavy metals like arsenic, other heavy metals that will be leached out. Then we have ion exchange, cation exchange, and another one is reductive dissolution of iron oxide. This is very important because this is the major cause of arsenic contamination in the Indo-Gangetic Basin. In the subsurface, that condition will be reducing. Then iron oxide that is stored in the sediment, that gas that converted to reducing environment, iron oxide will be dissolved, and that will release a lot of contaminants. Then we have dissolution of gypsum, anhydride, and halide, like these evaporites minerals. They also in the arid and semi-arid region, they have also important contribution to this salinity. Then we have cultural effect. We have already discussed a lot of cultural activities that generally leads to contribute this anthropogenic contamination. So let us first discuss about this rock water interaction. So what do we see here? The extent of rock water interaction that determines the chemical exchange between rock and water. So in this process, what generally happens, water percolates through the soil, and in the atmosphere, it gets carbon dioxide. Then what will happen? This carbon dioxide, that is weak acid carbon dioxide. So that will release these rocks, although it's a weak acid, but in the longer period, this carbonic acid that will act as a weathering agent and release out all those major cations, anions, silica, and heavy metals into the water bodies. So therefore, the water system solute in the concentration directly proportional to the bedrock material that will generally control this water quality. So if you can see one good example to understand this water interaction, one very good example is this silicate weathering and carbonate weathering. So what is generally happening? If you can see, silicate minerals react with water and carbonic acid. They generally produced this aluminosilicate and potassium, then silica bicarbonate. And again, this carbonate rock in the CO2 and H2O that produce calcium and bicarbonate. And remember here, there is two important things: silicate rocks that will release this element along with some non-soluble component will be there, clay content will be there. But when it will be carbonate, it will be easily dissolved most of the substance, and a lot of cations and anions are generated. Therefore, if the catchment on the subsurface having this carbonate terrain, then it will have high concentration of these elements, high concentration of these TDAs and other elements will be contributed. So already we have discussed this atmospheric deposition like sea salt. That is also because in the volcanic eruption, lot of gases along with these other components, sodium chloride, sulfate, is released. That also get into atmosphere, and through the precipitation or the wind that has been placed one place to another, that will deposit on soil, and again from the leaching process that will infiltrate and comes to the groundwater. Like volcanic eruption, that is a major, that a lot of ashes, and those ashes, volcanic ashes, pyroclastic material, they contain a lot of these contaminants, and that will also contribute to groundwater contamination. Then another major issue, that is saltwater intrusion, which is already we know, that is in the because of this excess withdrawal of groundwater, this hydrogen balance system is affected, and this saltwater is getting affecting to the contaminating to the freshwater bodies. So the finally, when you talk about this groundwater quality, then the final composition of this groundwater composition depends on the mineral composition of the aquifer materials. Then the contact time is, so that is the major factor that control groundwater quality. At the same time, it's not only this mineral composition of the rock type. At the same time, you will have this lot of chemical processes, dissolution, hydrolysis, adsorption, ion exchange. Okay, all those processes, they generally contribute these concentrations. So overall, they will control these major components, and that means macro and micro components in water. So now let's see what are those macro components in water. So when we'll talk about these macro components in water, we have these major cations and anions. In the cations, if you can talk about, that's calcium, sodium, magnesium, potassium. And anions, we'll have the major anions. We have this bicarbonate, carbonate, chloride, and sulfates. So these cations and anions, they generally dominate the TDS. If you call about the TDS, that will mainly contributed by these major cations and anions. So this will be generally this major component. It will be varied from 1 ppm to around 1000 milligram per liter of ppm. So generally in water, that composition, this major composition, the cation and anions, it should be chemically neutral. It's very important. Therefore, we have to understand this cation anion balance in water. So what will happen in the groundwater? Most of the cations and anions, it should be electrically neutral. That means, and this should be neutral based on the equivalent basis in the molar concentration. The molar concentration of the cations, it should be equal with anion. So this is called cation anion balance. This is the principle of water. That means whatever portions of these cations, the other means corresponding portion anions should be there. That should be balanced, because in water, calcium can be available with the calcium carbonate, calcium bicarbonate, or calcium chloride, calcium sulfate, something like that. Same like sodium can be sodium bicarbonate, sodium chloride, sodium sulfate, something like that. But when you will do the balance in the equivalent weight, this must be neutral. So if the water sample doesn't balance, that means if the cation is exceeding more than 10%, that means somewhere the analysis is wrong. That means the way we have analyzed, maybe somewhere we did the mistake or some other problems. But in general, the principle of this water chemistry is telling cation anions should be balanced. Then is the micro components. We have already discussed all those micro components, cation, anions, that means heavy metals, then radioactive elements we have already discussed. So these are the micro components in water. In the micro component, most important aspect we have discussed about heavy metals. So now we'll discuss about one of the important aspects when you talk about this geogenic contamination. One of the important aspects is we have to understand this hydrogeological setup of India. That means geological formation, soil type, then it's also physiographic, geomorphologic framework, climatic condition, because they have the important factor or the important driver of controlling this groundwater quality. So now if you can see, once we see this Indian subcontinent, it's very important to see, because we have to understand these major aquifers. So when you see these Indian subcontinents, we have 6 major countries. We have Pakistan, then we have Bhutan, then Bangladesh, Sri Lanka, along with India. So these 6 countries, they combinedly called, that is Indian subcontinent. And in these countries, if you can see, India is the largest country in the this Indian subcontinent. So now we can see these Indian subcontinents, if you can see the major river basins. This is very important. So what you can see here, we will have this Indus Basin. That is Indus Basin or Indus Aquifer, that is mainly this part that is between India and Pakistan. Then we have this Ganges Basin. That is Ganges Basin is here. Then we have Brahmaputra Basin. Ganges and Brahmaputra Basin Aquifer, that will be between India and Bangladesh. Then we have some tributaries of this Ganga that will be shared with Nepal and India. So now we can see how these hydrological set of in India, if you can see, this is the hydrogeological map of India. This is also same thing. If you can see based on this aquifer type, how it is distributed. Now we can see India includes a range of hydrogeological settings. You can see different hydrological setup is not uniform. And basically, if you can talk about the geological aspects, it's two different types. One is soft rocks, another is hard rock. The hard rock is characterized, if you can see most of these peninsular India, peninsular and southern part, central and southern part, if you can see. So that is hard rock. So these are the parts is hard rock. That is mainly characterized by the predominance of consolidated and semi-consolidated formation. If you can see consolidated or semi-consolidated formation, those are generally contain basaltic, granite, and crystalline rocks, and they are poor contain of groundwater. But if you can see other one, this soft rock here, soft rock is here. If you can see, soft rock is the characterized by the predominant of unconsolidated sediment. That part is the high storage of water. So those are sedimentary aquifer, that is mainly the Indo-Gangetic Brahmaputra basin. That is the major unconsolidated sedimentary basin. Those are the major aquifers is situated in this area. That means when you talk about groundwater contribution of different sectors, the groundwater mainly kindly in the majorly reserved in the three major mega river basin. That means the Indus, Ganges, and the Brahmaputra basin. And these three basins, they mainly contribute about 70% of the total groundwater. That means huge groundwater reserve is there. But if you can talk about rest, that is Indus, that means in the peninsular other part, that will be around 30%. So now we have discussed about this hydrogeological setup. Now we have discussed about these geogenic contaminants and the various type of contaminants. We have already discussed this water quality that is related to this major contaminant: arsenic, fluoride, selenium, uranium, chromium, hardness, salinity. If you can see, these are the major geogenic contaminants. And we have also anthropogenic like nitrate and salinity. They can salinity can also be geogenic, that I will discuss. And we have this nitrate. And if you can see, here is our Indian hydrogeological setup, along with, if you can see, this arsenic contamination is here. The blue content is the arsenic. Okay, then we have this pale orange color, that is the fluoride. If you can see the arsenic contamination, that is corresponding with the major river basin. That I will discuss later how it is related with this river basin. So therefore, these geogenic contaminants, if you can see, there is a much worrying level because of this high level of contamination, and they're almost contributing 70% of this groundwater resources. So this situation is really worrisome. A lot of, if you can see, lot of almost all over it's distributed that the groundwater is predominantly contaminated. So if you can see arsenic contamination, arsenic is the several states like West Bengal, Bihar, mostly in the arsenic contamination in the Indo-Gangetic basin. That is highly contaminated with arsenic. Then fluoride, we can have a lot of states like Andhra Pradesh, Bihar, Gujarat, Haryana, a lot of other Madhya Pradesh, they're also affected by fluoride. Then we have also iron contamination. It's also a lot of states like Odisha, Chhattisgarh, Assam, Bihar, Punjab, they have also high concentration of iron. Then we have this uranium contamination. We have already discussed, then we will also discuss in detail. Uranium contamination in generally in the northwestern, southern and southern eastern India, we have this uranium contamination. Then we have nitrate contamination, you can see a lot of states also, Haryana, Himachal, Bihar, Maharashtra, Odisha, then West Bengal, they have also problem. Then we have this salinity, we have two different types of salinity, inland salinity, then coastal salinity. Coastal salinity mainly in the Sundarban region, Pondicherry, then we have Gujarat, those area, coastal salinity, and we have this inlet salinity mainly in the arid and the semi-arid region. So now let's talk about this arsenic. As you know, arsenic contamination, arsenic is a metalloid and it has been classified as a class 1 human carcinogen. And according to this permissible limit, arsenic is almost 10 pp, the permissible limit WHO, then BIS, Bureau of Indian Standard, that is about 50 ppb. And here is very important to see, that is according to this chemical abstract number registry, that is the agency that has been cracked, that has been listing all those major contaminants. Now if you can see, this arsenic is the rank 1, that means arsenic ranked first. This clearly indicates something, arsenic is something very bad for human health. Arsenic has been, although it has been used in the medicine, but if you can see, this is also, it's a very important to understand because it's very contaminant. If you can see arsenic contamination, if you can see it's arsenic contamination, that is one example. If you can causes ulcer on legs. So here, if you can see how it affects this arsenic, first is causes skin pigmentation. If you can see, skin pigmentation will be there. And remember, the arsenic poisoning, it's very slow poison. It's a very slow process. You cannot, if you drink even high level of arsenic, you cannot, this kind of effect will not happen in within a month or week. If you will drink this arsenic contaminated water for a longer period, then you will have slowly this type of impact will be happen, disease will happen. The first cause, if you can see, the first it will arise this pigmentation, skin pigmentation will be there. Then we have this gangrene, you can see this gangrene, the leg, if you can see here. Then we will have a lot of ulcer, if you can see. Then slowly you will have this cancer, the skin cancer, then bladder cancer, all of these cancer diseases will be there. And finally it causes death. So arsenic, we all know arsenic is a natural element. Also, it's abundant in earth crust. If you can see in the earth crust, its concentration is 1 to 2 ppm, and also in some of the sedimented rocks, it's contained a very high concentration up to 400 milligram per liter. And arsenic can also contributed from various kind of anthropogenic activity like agriculture, by these pesticides and all those industrial activity. So if you can see the geochemistry of arsenic, arsenic is mainly two important major species. One is arsenate, another one is arsenite. And remember, this arsenate, that is arsenic plus 5, and arsenite, that is plus 3. That arsenite is more toxic, that is almost 30 to 60 times more toxic and more mobile than arsenate. Therefore, arsenite is more threatening for human health. So generally, if you can see this chemistry of this arsenic generally, it generally precipitate, or it generally scavenged by primary and secondary minerals. First, let's talk about some of the primary minerals, which are sulfide minerals. So arsenic will be in the pyrite and arsenopyrite, that will be there, and some secondary hosting minerals like iron oxides, mostly that is goethite, jarosite, ferrihydrite. Most of these secondary iron oxide, hydroxide minerals, they generally scavenge this arsenic. And these secondary iron oxide, hydroxide, they generally called as a temporary storage of arsenic, because they just hold this arsenic for a temporary means for the temporary period, because based on the environmental condition, the arsenic mobility will be changed, because these iron oxide, hydroxide, they're more stable in oxidizing condition. But when the condition will be reducing, so these iron oxide, hydroxide will be dissolved, and again they will contribute arsenic to groundwater. Okay, and arsenic is also released in some hydrothermal activities. They contain high concentration of arsenic. So let's talk about what are those major process, because we have to understand two different things. One is the origin, another is process. So what are those major processes that causing arsenic rich groundwater? The first one, we have three major processes: sulfide oxidation, desorption from iron oxide, then another one is reductive dissolution of iron oxide oxides. So the first one is pyrite oxidation, that is oxidation hypothesis. What you can see here, if you can see, that pyrite, that is also associated with some minerals, sulfide minerals in the subsurface, in the aquifer. Okay. So what generally happens, those aquifers, when the water table will be very high, okay, so what will happen, there will be no such problem. But when the lowering of water table, then what will happen, these sulfide mineral exposed, because of this excess withdrawal of groundwater, these sulfide minerals will be exposed to this oxidizing condition, because through the rain, oxygen will be mixed up with this rainwater, then that will infiltrate and comes to the subsurface. And in subsurface, those oxygen, if it will be, the water table will be down, what will happen, those sulfide minerals will be oxidized and it will produce arsenic. So like this, if you can see, iron, these sulfide minerals, then this they get oxidized, and also this ferrous, ferric, it releases ferrous sulfate along with this arsenic. Then another problem is dissolution of arsenic rich iron oxide due to reducing environment in the subsurface. This is the most crucial and important process that generally causing arsenic contamination in West Bengal and Bangladesh, which is the most arsenic affected areas. So what generally happens in the oxidizing conditions, what will happen, this arsenic generally gets eroded from some of those means primary sources, and it will precipitate in the sediment, because in the sediment that contain iron. Okay, iron has scavenging potential, they will temporarily store this iron oxide. So in the oxidizing condition, these iron oxide, they will be very balanced, they don't have any problem. But when the condition will be reducing in the subsurface, this iron oxide will be dissolved, or it will be iron oxide, that means +3 will convert it to +2, that will release arsenic. Okay. So if you can see something, if you can systematic diagram that, if you can see distribution of arsenic in the multi-layer in the alluvial aquifer, if you can see how this arsenic is deposited, okay, along with this stream beds in the sediment deposition, arsenic is getting deposited, and this arsenic, when the condition is getting reducing from this iron oxide hydroxide, that is slowly releasing arsenic to groundwater. The second mechanism, this one is the major mechanism. Then another one is release of arsenic that has been released by the competitive exchange with the phosphates. This is one of the, although it's an anthropogenic cause, what is generally happening, because of the excess fertilizer, this phosphate will be there, and phosphate will make a competitive behavior with arsenic. Therefore, it will leads to desorption of arsenic from oxyhydroxide surface, and this will lead to the excess application of fertilizer. So this will be also one of the regions where in the Indo-Gangetic basin, where a lot of arsenic has been, that fertilizer has been applied, that can be one of the process. Then another process is alkali desorption. That means some of those in the alkaline condition, suppose at very high pH, what will happen according to this iron oxide surface, at high pH, that iron oxide will be in the high pH, it will be negative, the surface will be negative. Then this arsenic, because it will be, it is oxyanion with oxygen, it is oxyanion, it's a negative surface, then there will be a repulsion, then whatever the arsenic will be there, that will be dissolved from iron oxide surface. Therefore, this is also another important process for releasing arsenic. So if you can see, this is one the process we have compiled. And if you can see, a lot of arsenic release mechanisms, that is oxidation of sulfide, redox dissolution of iron oxide, then desorption of high pH. If you can see, A is oxidation of sulfide, B is redox dissolution of iron oxide, and C is other is a desorption at high pH. If you can see, most of the studies, particularly these our Asian context, Indo-Gangetic basin, the major process is B, that is reductive dissolution of iron oxide. So this is another one. If you can see, although there are several processes, the probability of arsenic release, the major mechanism is the redox transformation. That means reductive dissolution of iron oxyhydroxide is the major mechanism that causes arsenic. Now you can see in the Indian scenario, this already we have discussed this Indo-Gangetic basin. If you can see, the major arsenic contaminant region is here. So that arsenic contamination that has been reported in 1983 from 33 villages from West Bengal. So this is mainly, and after that we have this Chhattisgarh, Bihar, Assam, other places that has been reported. So now if you can see this arsenic is mostly, this is the Indo-Gangetic basin that is mostly covering the Bangladesh and West Bengal, if you can see. So now what you can see, if you can see now, compare to understand little bit the source here, where the arsenic is coming from. So this is according to a recent study, this Mukherjee et al. 2015, what they have studied. This is the hydrological setup of India. Now if you can see, this is the arsenic distribution. Now if you can see, if you can compare these arsenic contamination with the river system here, if you can see here, this river basin, what you can see, the pattern is pretty much similar. That means this pattern is pretty much following the river valley, that is Ganges and Brahmaputra. So here, if you can see Indian perspective, almost 233 millions of Indians that is generally affecting by this arsenic contamination. And if you can see, most of this Indo-Gangetic basin are mostly polluted by this arsenic, like states like West Bengal, Bihar, Assam, like these states. And also, if you can go in detail, how arsenic might present in the overall, all over the world. It's not only a problem in India and Bangladesh or in the Indian subcontinents. If you can see, as you can see, this arsenic, it has been a huge problem in other worldwide. If you can see, this is the North America. Then if you can see the South America. However, when you talk about the arsenic contamination, it was very hyped and seriously reported that arsenic contamination is really severe in the India and Bangladesh. Now you can ask why this is, even if this North America, South America, still there, the contamination is huge. Why it is most highlighted this India and Bangladesh? So this is due to the higher number of people affected due to this high density. If you can see this Indo-Gangetic basin, the density of people are really high compared to this region. Therefore, more number of people are getting affected this region. So now if you can see here, the Asian context, the proportion of global affected population, if you can see number of more people, they are affected in the Asian zone compared to other part of this globe. So now a little bit, let's talk about the source. Already we have discussed about this Indo-Gangetic and Brahmaputra Indus basin. And now you can think something, you might be suspecting something wrong here in the Indo-Gangetic basin. So this one we have already discussed, how this river pattern is pretty much similar to this valley. And again, if you can see this one, this is also very important to see how these arsenic contamination, the source of this contamination. So now if you can see, these are the area, the major foreland basin. Foreland basin, all these, if you can see, that is foreland basin, then orogenic basin. If you can see here, the arsenic contamination, if you can see North America, South America, and even in the Indo-Gangetic Himalaya basin, mostly the arsenic contamination is concentrated in the foreland basin. Foreland basin means that is the developed, that basin is developed adjacent or parallel to a mountain belt, and that is adjoining to orogenic belt. Orogenic belt means, orogenic means that is the process of mountain form the building. For example, if you can see this basin close to Himalaya, this Indo-Gangetic basin in India, Bangladesh, this basin, if you can see this Himalaya mountain, so that is how this Himalaya mountain is formed. Himalaya mountain is formed between the collision between the Indian plate and Eurasian plate that was begun in 50 million years ago. And same thing, if you can see here, that is the Andes mountain. So these are foreland basin as the major groundwater aquifer across the globe. So these basin adjoining the orogenic belt are the major polluting source of arsenic. Now if you can see, to little bit more elaborate this aspect, what you can see, there is a study that Mukherjee et al. They have collected this water sample from various aquifers. That 63 major aquifers they have collected, and they get to know this foreland basin. Okay, foreland basin. So generally that is close to this orogenic belt. Okay, so that generally contain high concentration of arsenic. And it's interesting to know that this foreland basin, this is related to the plate tectonic point of view, because this is generally, this is mostly associated with the convergent boundary. Two plates, they just approach each other, collide, and this basin is Foreland basin is formed. Therefore, it shows this dramatically, this convergent aquifer basin means these foreland basins, they're mostly contaminated by arsenic, and this clearly indicates that tectonic play a major role is influencing the groundwater chemistry. And if you can see, most of these highly cited and good paper, that is Journal of Hydrology and Science of Rural Environment, they clearly deduce this mechanism. That means how this tectonic process, one of the major process that control this arsenic contamination. So if you can see, this is one this tectonic process. This model generally depicts how these plates subducts in the subsurface and generate these partial melts. And at these partial melts, as it goes to this thick continental plate, it will dehydrate and generate metasomatic deposits, and that generally release this incompatible arsenic. That is the major source of this arsenic. So here, same thing, if you can see this Himalayan belt, Himalayan also derived this arsenic enriched sediment, whatever the Indo-Gangetic basin we have seen, that is getting eroded from this Himalayan mountain. That the parent rocks in the Himalayan mountain that generally contain these arsenic enriched sulfide minerals, and those minerals get weathered, and that has been transported by the river basin, and they get deposited along this Indo-Gangetic basin, and those arsenic along with the sediment, they get deposited, and through the deposition there is a subsurface redox condition happened, and that generally release this arsenic to groundwater. So like this, if you can see, through this tectonic and volcanic activity, this weathering happen from these parent rocks, then this is transported to the system. Same thing is another, you can see this is source, chemical weathering, this rocks comes to this through the river channel sediment, it's get deposited, and this is coming to groundwater. Same thing we can see in the Indian perspective, that is also a huge problem in West Bengal, already we have discussed. So, excuse me. Hello.
जी सर, जी डॉक्टर साहब, जी
सर कितना मिनट मेरा बचा है अभी?
सर अभी तो सर आप आधा घंटा ले सकते हो सर.
Okay, आधा घंटा. Okay, thank you. So am I audible to everyone?
Yes sir, बिल्कुल सर, perfectly audible sir.
Okay, thank you. So next we will talk about, because I have to little bit hurry off because I have a lot of slides. So let's talk about this arsenic contamination in Bengal basin. So generally in the Bengal basin, what we have seen, there is this study indicates. So mostly this is a very peculiar behavior. If you can see, most of this Bengal basin, whatever the studies they have done in the different places, that almost 60% of the sample they are highly contaminated. And if you can see, most of this water that has been the shallow aquifer, mostly in the Lakshmipur and Faridpur, mostly shallow aquifer, they generally exceed this WHO limits. And if you can see this arsenic, how it is related with other parameters, this is very important to understand these arsenic mechanisms. Okay, so that means arsenic is perfectly significantly related with the iron. That means reductive dissolution. If you can see, that means iron is also releasing when the reductive dissolution happens. And at the same time, if you can see strong correlation with ammonia and methane, this is very important because this will tell about this microbial activity that generally facilitating these arsenic to groundwater. So I'm not going in detail this aspect. So next is the how to understand this source of this arsenic. They have also studied about the sediment because it's very important. So once we have this sediment, if you can see how this sediment in the subsurface that is very closely associated with the groundwater, this indicates this sediment is the major arsenic holding source that releasing this arsenic due to various type of processes. Therefore, if you can see, arsenic adsorbs and arsenic adsorbed then adsorbed iron, because this iron oxide hydroxide is the major scavenger of arsenic in the sediment. So now this is very interesting fact. If you go to the depth, if you can see in the shallow sediment, we will have, if you can see, there is in the sediment there is high concentration of arsenic, but in the deep we will have very low concentration of arsenic. What does it mean? That means in the deep, that will be The groundwater flow, this is another important, because groundwater flow in the means a deeper zone, that will be faster. That will means disturbing this hydrological system. Therefore, the arsenic is not concentrated because it's diluted. Almost the arsenic is the water is momenting. But in the shallow aquifer, you can see this is the slow movement water. Therefore, whatever the arsenic is released, that is remain there. Therefore, the arsenic concentration is more there. And this is the process, as we have discussed, that is reduction dissolution. That's the major role of this microbial activity. How this microbial activity, they generally, these anaerobic bacteria, they generally degrade this organic matter in the subsurface, and that leads to release arsenic. So there is another important aspect. What is important? This groundwater. Once this groundwater is affected, groundwater is also affecting not only the people will get exposed to the through the groundwater. They also, this groundwater used excessively for the irrigation. And once the irrigation will be contaminated, groundwater will be used for the irrigation. What will happen? That will accumulate in soil, and ultimately that will be taken by these food grains. So that's why in the alluvial aquifer, that is the most threatening, not only for the groundwater, for the drinking, also for the food security. So what we have studied, this is the study I have done in my Korea. So we have studied arsenic contamination in the groundwater in the alluvial aquifer. So what we have done, we have in this study, we have drilled some multi-level wells, that means agricultural well, and the multi-level sampler we have installed by using this kind of multi-level sampler. From the different depth we have collected to understand this arsenic. So what we have seen, that arsenic concentration were low at the shallow aquifer. If you can see, that is low, but at the shallower and greater at the depth. Once you go deeper, if you can see, this is in the shallow aquifer, this is the high concentration of arsenic. And again, if you can go more deeper, that the concentration will be low. But at the same sites, if you can see, arsenic concentration that increased with the depth at shallow and decreased at the greater depth. So this is the typical vertical distribution pattern of iron oxide hydroxide reduction, and that is the main mechanisms that generally release arsenic. Now it's very important to see how the anthropogenic factor control this arsenic mobilization. So now you can see other parameter, pH, alkalinity, lot of parameters we have discussed. The most important thing I need to highlight here, one is nitrate. If you can see nitrate in the shallow aquifer, because mostly contributed from the agricultural activity. So once the nitrate content will be higher, that will suppress this arsenic concentration, because nitrate will be act as a oxidant. That will make an oxidizing condition. Then the reductive dissolution will be suppressed. Then another component is sulfates. Sulfate, what will happen? If you can see sulfate behavior, that will be high in the surface, and again in the deeper we will have this sulfate concentration is reduced. So what you can see, this sulfate in the deep aquifer, okay, that sulfate generally act in the reducing environment. Sulfate will react with this iron. That will be, iron will be in the +2 form. It will form sulfide mineral, and those sulfide mineral, they have even absorption capacity for the arsenic. Therefore, if you can see this study, what we can understand, this surface condition, surface geology condition, that means nitrate and sulfate concentration, that those are generally coming from these agrochemicals. Okay, so they can regulate arsenic concentration in alluvial aquifer. So now we'll talk about this fluoride contamination. We all know fluoride contamination. This is also another important problem in India. And fluoride is very important because fluoride is one anionic element, and it's very reactive, highly reactive. It's very important. Mostly highly reactive chemical elements that is available on the earth crust. That is the 13th most abundant element. And if you can see, because of this highly reactiveness, this actually react with other components, other elements. Therefore, it has several associated with the other elements. So, but fluoride has a dual behavior, dual-edge behavior. That means in the low concentration, fluoride is beneficial on the teeth, but in the high concentration, it will have this skeletal and dental fluorosis. So if you can see, this is a very simple diagram. What you can see, this fluoride concentration, fluoride, because the particle size, it's almost similar, and charge is similar with OH minus. Therefore, fluoride is easily replaced OH in various kind of minerals. Now, if you can see how it is in the lower level, how it is affect to the dental, because in the dental, our the teeth, that is 95% of the teeth that is made of a hydroapatite. Okay, and this hydroapatite mostly on our teeth, but when the condition will be acidic, this hydroapatite will be easily eroded or easily leached. But what will happen in that same place if there will be in the hydroapatite, since fluoride is exchanged by OH, when this fluoride will be converted and interact with here, that will form fluoroapatite formation. And this fluoroapatite, that is really very important because it will resistance to weathering. Therefore, whatever the dental carries, it really help for this kind of problems, because this presence of this fluoride that will be replaced by this OH here in the this apatites. So, but what has happened, this fluoride concentration in the higher level, this is in the higher dosage is causes dental fluorosis, which is characterized by staining and pitching of the teeth. And more causes, it causes various kind of enamel problem, and also it causes higher level causes skeletal fluorosis. Then we have bone problem that will be like this. If you can see in the low concentration, if you can see below to 0.5, 1.5, up to the permissible limit is 1.5. And exceeding that level, that causes dental fluorosis, skeletal fluorosis, and other problems. Here, there is another problem. You can see, if you can see the mild fluorosis, then you will have the, if the concentration increases, then you will have a moderate and severe fluorosis. So now let's discuss about this fluoride contamination. Fluoride contamination also is a major problem. Almost 70 million people that has been affected. And also this fluoride is a major in the one of the widespread element in the on the earth crust. And in the fluoride concentration of this contamination is also highly dependent upon the geological condition, because fluoride is commonly associated with fluoride minerals like this fluoride, FeUrite, CF2. Also, along with it, it's associated with this apatite and biotites. So if you can see this, how this geology control this fluoride contamination, if you can see most this fluoride concentration that enriched in the basaltic and the igneous rock, they have very high concentration. But if you have this sandstone, this is a sedimentary sandstone, and the limestone, the concentration is very low. But in the sedimentary, if you can see these phosphorides, because phosphorides also contain this OH, that OH can easily replaced by this fluoride. Therefore, these phosphorides contain high concentration of fluoride. Along with the volcanic rocks also contain huge amount of fluorides. So generally, if from this figure, what we can see, this fluoride weathering and fluoride source, generally this is the weathering of fluoride, this is the magma, and this is the volcanic eruption, the volcanic activity and the geothermal activity. These fluoride rich components come up to this environment, and they just precipitate with the minerals like biotite and other amphiboles, and in the granite bearing rocks, they generally control fluoride control. That those minerals, they get weathered, and through the hydrogeochemical process they get leached, and it contribute to water system. Along with, we have also fluoride contamination. We have discussed about this geothermal activity in the area of volcanic activity. They also release fluorides, and also sea spray. That is also because in fluoride also abundant in seawater, almost 1.3. But when this sea spray that will be accumulated, they also contain or contribute fluoride contribution. Along with, we have this anthropogenic activity like this aluminum smelter, fertilizer. Fertilizer is one of the important because of this phosphate fertilizer that is being used, these phosphorite rocks that also contribute fluoride to environment. So this is the worldwide aspect. If you can see how this groundwater fluoride distribution is happening in the several states, several countries, they have been affected by this groundwater. Now, if you can see how this is related to the lithology, if you can see most of the world's high fluoride district coincide with the area affected by volcanic activity. If you can see, volcanic and geothermal domain is here. That means this region underlined by the crystalline and igneous metamorphic rocks and large sedimentary basin, and also in the sedimentary, most of the semi-arid region, they are also containing this arsenic contamination. And this fluoride contamination, if you can see, in India, that fast occurrence of fluoride that was reported in Guntur district in Andhra Pradesh. But now, if you can see this fluoride contamination, it's really very serious concern, because the many states we have affected by this fluorides. You can see this Andhra Pradesh, Gujarat, then Rajasthan, these are the most affected countries by this fluorides. So this is also one of the study we have done in the Malabar region. If you can see Bathinda, Talwandi Sab, also in Fazilika, some of these districts, they have also contained this fluoride concentration is really high. Generally, greater than 1.5 according to WHO, that is the fluoride concentration leads to harmful effect. If you can see, some of those fluoride concentration is really exceeding. So now we have to discuss about this major mechanisms, how the fluoride is released. As we have already discussed, fluoride ions have the same charge because it's nearly the same radius as the hydroxyl ion, that is OH. If you can see here, fluoride is always replaced by the OH. And OH is a very common mineral, common component in the silicates and the various kind of phosphorides, other rocks and minerals. Therefore, this OH is replaced, fluoride is replaced by this OH, and it's get into these minerals. So now we'll discuss about what are the major mechanisms that generally we have discussed about the source where the fluoride is coming. Now we'll discuss about the factors that responsible fluoride mechanisms or the fluoride mobilization. So what is the major things? As we have discussed, fluoride extends between OH and fluoride because both have the same charge and same ionic rating. So therefore, what will happen? These fluoride bearing minerals, they generally release, and the condition will be most favorable when there will be high concentration of sodium and bicarbonate. This is the most favorable condition because in the bicarbonate, when there will be more bicarbonate, it will be more alkaline, and that will be increase the alkalinity, that will give a favorable condition for the leaching of the fluoride from the host rock and the minerals. Okay, therefore high sodium and bicarbonate concentration is very important. But at the same time, if the water contains very high concentration of calcium, calcium generally precipitate fluoride, that is formed calcium fluoride. Therefore, in the fluoride enriched area, you will get high sodium and bicarbonate, but you will get a very low calcite. Calcium will be precipitated as a calcium carbonate because at the high pH, the calcite solubility will be decreased. It will get precipitated as calcite. So we have discussed, therefore the main occurrence will be bicarbonate and sodium. They are the major contributor or the major, they'll facilitate this fluoride through groundwater. So this is one study we have done in the Balangir district in Odisha. This is the most of this geology mostly continue. If you can see this granite rocks, they're also major contributor of these fluorides. So here, if you can see, there's a comparison between surface water and the groundwater in the same area. If you can see, the surface water doesn't contain fluoride, very low concentration. But in the groundwater, if you can see, that is average is 1.5, then it's up to 4.25 concentration of fluoride is there. That means you have to think of here, that means subsurface weathering, this favorable condition is happening and rock weathering is happening. Therefore, this fluoride is coming. So now we can see this, to understand this mechanism, we have to understand what are those major water types of water. If you can see various type of water types that has been classified according to Piper diagram. So most important type is sodium bicarbonate. You can see this is the phases that generally lead to high concentration of fluoride. Now we can see how this sodium and bicarbonate is very positively related, strongly positively related, because they facilitate this fluoride mobilization. But calcium is negatively correlated because calcium, once the calcium get precipitated, then fluoride get liberated. So if you can see, that is a positive relation between fluoride and pH, because the alkaline condition fluoride get released. And same thing, if you can see sodium fluoride, sodium bicarbonate, but you have negative relationship with this fluoride. Also, we have calculated this saturation index to understand these mechanisms. What you can see, this fluoride is, hello, something happened. Hello.
Ji sir.
So
Yes,
are
sir.
you telling something to me?
Any participant want to ask anything?
Okay, I'll first finish it off. So then what we'll discuss, when we will discuss about the different rock type, if you can see this groundwater in the granite terrain, if you can see very high concentration. But in the other kind of rocks, condolite, something like that, the concentration is low. So this indicate that means local geology, that means geological setting play an important role. And along with this hydrogeochemical process, that means bicarbonate type and the high pH, they are the major process releasing fluoride. Along with in the arid region, arid and semi-arid region, what generally happens due to the evaporation, high evaporation, what generally happens, the calcite get precipitated, then that really accelerate this fluoride solubilization in water bodies. So now we'll talk about this uranium contamination in groundwater. So as you know, uranium is a radionuclide, and if you have three isotopes, 233, 235, and 234, but uranium 238 is the most abundant element in the earth crust. So generally, this uranium concentration, if you can see on the earth crust, it's almost 2.8 ppm, and USCPA, the concentration is 30, and according to this atomic energy permission limit, that will be around 50. Sorry, this one is 50 ppb, not ppm. It's a mistake. And this uranium that generally affects kidney, liver, and bone. Now, if you can see this uranium contamination problem in India, it's a very significant. But if you can see high uranium concentration in several states, if you can see high uranium concentration that has been in several, if you can see that has been in Andhra Pradesh, Chhattisgarh, Gujarat, Maharashtra, then Haryana, Punjab, lot of states, they have high concentration of this uranium in groundwater. So now if you can see, what are the major factors responsible for this uranium contamination? The first thing is that uranium is the source rock, that is the aquifer rocks, and mostly this is volcanic and this granite rocks, that is the major content of this rock, and along with some hydrogeochemical process like oxidation condition, then we have other anthropogenic factors, they facilitate this uranium mobilization. So this is the average uranium concentration. If you can see, if it will be uranium deposit, it will be very high concentration of uranium. Then we have this granite rocks, volcanic rocks, then sedimentary rocks also contain high concentration of this uranium. And remember this uranium, like arsenic, we have discussed about arsenite, arsenate. Here same thing, uranium also two different redox species, different species. One is uranium-4 and uranium-6. And uranium-4 is the reduced species that is really immobile, that is not available. So that will be associated with the volcanic rocks and these granite other things. But when you talk about this uranium-6, that is generally mobile. So that means these uranium species, that will be uranium species, that will be more species in aqueous species, and it will be more available in groundwater. And when you talk about the mineral dissolution, what will generally happens, this increase of this dissolved carbonate concentration, carbonate and bicarbonate concentration, they generally make favorable formation with this uranium species, uranium-6 bicarbonate species. That is the major means mobile species that is available in groundwater, and that generally facilitate uranium solubilization. Therefore, what you can see for the uranium contamination, one is water interaction. Then other things we have discussed about this mobilization under oxidizing condition. It's very important. In the oxidizing condition, that will be this fluoride, this uranium will be mobilized. Then other condition we will have alkaline pH. Then we will have this bicarbonate concentration should be there. Okay, because uranium concentration increased with the increasing with bicarbonate, because that will form this uranyl bicarbonate species. That is the oxidizing species that will be available in the alkaline environment, which generally favorable. Hello. Hello.
All participants are requested to keep your mic sets on mute, please. Sorry, sir, you can continue, sir.
Okay. So then we have other things like increased alkalinity and pH. Therefore, we have to understand what are those major factors. Increased alkalinity, pH, bicarbonate, they generally facilitate uranium from the rocks to groundwater. Therefore, when you see the relationship, if you can see in the groundwater, if you can see high alkalinity, TDS, bicarbonate, EC, they are mostly positively correlated with this uranium concentration. So this is the mechanism we have discussed. That means uranium will be facilitated in the oxidizing condition. Once the oxygen get penetrate, So that will be the uranium-6 species will be there, and that will react with this carbonate, and in the bicarbonate at the alkaline pH, that generally facilitates uranium mobilization. So another important factor, uranium is often a co-contaminant with nitrate. So this is one of the major problem in Punjab. What generally happens is Punjab in the groundwater, they generally apply a lot of nitrate fertilizer. So what generally happens, this nitrate can abiotically oxidize this uranium-6 and that yielding aqueous uranium-6. Therefore, this nitrate, therefore, in the Punjab, in some of this region, you will find strong correlation between uranium and nitrate, along with alkalinity and calcium. And these nitrate act as a catalyzing agent to facilitate this uranium concentration from groundwater, from the rocks, and that will enrich the concentration in the groundwater. This is some other region also reported how this uranium concentration related with the nitrate. If you can see some of these, wherever the nitrate enriched, the same region is enriched uranium. So this is the situation in the uranium contamination in the Bathinda, in the Malwa region. If you can see 3 important like Bathinda, then we have Barnala, Ludhiana. If you can see very high concentration of uranium. The major cause of this uranium concentration is these granite rocks, along with these other contaminants like as I discussed about this nitrate. They also facilitate this uranium concentration. But the major origin is the Tosam Hill granite, as it has been reported by the Central Groundwater Board. That is the major source. So if you can see this Malwa region, it's not only this uranium, they have other arsenic, nitrate, and also fluoride contamination. It's significant. Then we have discussed about this iron contamination, which is a very common contaminant is iron, because as you know, iron is an abundant element. It's almost the third, it's an abundant element on the earth crust. And also if you can see in the crust, we'll have almost 5%, and the core, it's the most dominating element that is contained around 91%. And if you can see this iron contamination, that is several states. So if you can see here, several states, they have this high concentration of iron. And according to WHO permission limit, that iron concentration is 0.3. That is ppm, and this iron contamination you can find a lot of states in West Bengal, Rajasthan, Odisha, Goa, Haryana. Lot of states if you can find high concentration of arsenic. And of course, arsenic is iron. Iron is it's a geogenic because we have contained a lot of these iron minerals, also iron oxide. That is the general means major source of this iron, and also some of those hydrogeochemical process like reducing condition, more iron concentration will be there, more ferrous concentration will be there, more iron oxide dissolution will be there. So they also contain iron concentration. So now another important problem, we have this salinity. Salinity is nothing but the total dissolved salt contained in the water. Salinity is generally measured in the unit ppt, that is parts per thousand, or in the percentage. So generally in the salinity, if you can see, the salinity is varied widely, and based on the salinity, the different water types has been classified. And in most of these high concentration of salinity, that is also very important to understand, because it causes effect on the plant growth. If the saline water has been irrigated, that will generally damage the crop and also affect growth, and also it will degrade the groundwater quality. So now if you can see, is this salinity, that is we can also measure based on the TDS, that is total dissolved solids, that is measured in milligram per liter. Okay, even from the EC, electrolyte conductivity, there is a factor you can multiply, you can also calculate salinity. Then salinity is nothing but the salt content, mostly this measure cations and anions, mostly this chloride, sodium nitrate, calcium, magnesium, all those they generally contribute to salinity. And the salinity, the important thing we have to understand here, that is two different problems, salinity problems we have. We have this coastal salinity, then we have inland salinity. Coastal salinity, that is mostly we have observed in the coastal belt, like in the Pondicherry, Gujarat, Andhra Pradesh, Tamil Nadu, some of those because of this seawater intrusion. If you can see this coastal belt, some of this coastal salinity that has been very serious. But along with, we have this inland salinity, and inland salinity is generally prevalent. It's very more dominant in arid and semi-arid region like Rajasthan, Punjab, Haryana, Gujarat, something like that. Then what is the reason of this inland salinity? Inland salinity, first major thing is that high evaporation and over exploitation of groundwater. So generally what happens in this region, there is a scarcity of rainfall. So what generally happens because of this scarcity of rainfall, the water is not getting diluted. So whatever the minerals getting a rock weathering is happening, they are even concentrated. Those waters is getting concentrated with soluble salts. And along with, they have another problem. Inland salinity is also aggravated by improper irrigation practice. So what generally happens in the some of the place, they generally practice this surface water for the irrigation without considering groundwater. So once the excessive surface water will be used, then without considering this groundwater, so during the precipitation, what will happen? This groundwater level will increase, and those salt content will comes to the soil, and it will increase the salinity. So this kind of problem is severe in Rajasthan and southern Haryana, where the EC content is more than 10,000 microsiemens per centimeter. And even some of those areas like Rajasthan, Gujarat, this problem is also even serious. So this is another one of the important challenge. If you can see, this is how this salinity is affecting. There are several states. The most 10 worst, top 10 salinity contaminated countries, we have this Gujarat, Haryana, Andhra Pradesh, Karnataka, like these states are affected. So now this another contaminant we have to discuss about this nitrate. So nitrate, we know nitrate is also the permissible limit as per this WHO is 50 and BIS limit that is 45. And drinking water is a very common contaminant, nitrate, and because of this excessive application of this nitrogenous fertilizer and excessive irrigation, that leads to contribute nitrate contamination. And drinking water nitrate contamination, one of the major problem is methanoglobinemia. Along with it causes gastric, cancer, goiter and birth malfunction. So this is, we have discussed about this nitrate by this anthropogenic causes. But along with this, nitrate can also generate from this geogenic process. What you can see, the formation of nitrogen is the integral part of this nitrogen cycle in our environment. If you can see, atmosphere nitrogen here, it's getting converted to ammonia, then subsequently nitrate, and is deposited in soil, and generally through the rainfall and other modes of precipitation, that is contributing this nitrate. And along with some of the bedrocks, they also contain some minerals like tobelites, suhalite, nitrate, they also contain this nitrogen. Therefore, this nitrate, although the major reason is anthropogenic, also some of the geogenic process that leads to contribute this nitrate contamination. And if you can see in the nitrate contamination is the Malabar region, is a very predominant. If you can see several region like Bathinda, Talwandi, and also if you can see that is in Fatehgarh Sahib and some of the Barnala, some of the region, they have reported very high concentration up to 230. And this nitrate is mostly the anthropogenic causes, mostly by excessive use of fertilizer. If you can see Punjab, the statistic, if you can see mostly Punjab, the nitrogenous fertilizer, if you can see, it's very predominant. Along with it, they're also using a lot of these pesticides, other things. So they causes this lot of this nitrate contamination to groundwater. So now what we can see in the summary of this lecture, what we have seen, this groundwater contamination was one of the major important issue in India, also in the worldwide. As we know, 80% of the groundwater in India is dependent on groundwater. And this groundwater uses we have already discussed, and the major groundwater uses we have learned about the agriculture. And agriculture is most of this Indo-Gangetic basin, this Punjab, Haryana, Rajasthan, all of this, they have excessive withdrawal of this groundwater for the agriculture purpose. They are even threatening this ground imbalancing, they are destroying this groundwater balance, and as well as that is also facilitating this geogenic contamination. And this contamination we have already discussed. This hydrogeological setup, we have one of the major problems that controlling occurrence of this groundwater contamination. For example, this arsenic contamination is mostly confined to the Indo-Gangetic basin. Along with this, that is covering the West Bengal, Uttar Pradesh, and Bihar. Along with it, we have discussed about fluoride, nitrate, iron. This is the various several other states that has been impacted, and those are even the problem is serious. We have also discussed about this salinity, inland salinity, then coastal salinity. Coastal salinity is due to seawater intrusion because in the coastal area, because of the excessive withdrawal of this fresh water, the groundwater table is getting declining. Then the saline water is getting into this freshwater system. And we have also discussed about this groundwater contamination in the Malwa region in Punjab. We have discussed some of those. Uranium fluoride nitrate is quite significant. And the challenging thing is that in the groundwater contamination in Malwa region in Punjab, what we have seen, a lot of this contamination we have seen that has been reported. And also this contamination source and this hydrogeological process, still a lot of things still needs to be done. That is what are the challenging. What we have seen, a lot of contamination there, but still, although that has been reported, that is Tosa mill granite is the major source of this fluoride and this uranium, and also these some of those hydrogeological process, still some of those processes are still not discovered yet. Because the most of these groundwater studies that has been conducted in this region, what they have done, they have conducted groundwater from the single depth. Okay, that is very basic problematic. You cannot even understand if you collect groundwater from a single depth, borewell or the tube well. As I have discussed in one of my slides, we have collected groundwater sample from the different depths. That is the major challenge. If you collect sample from the different depths, that you will understand the natural characteristics of this groundwater along with these geochemical phenomena or these contaminants. That will make you understand to how these or what are those processes generally controlling this groundwater contamination. So these are the major challenges we have to focus on these aspects. And also, although this contamination is quite significant, what we have seen, but at the same time, we have to also think of this management aspects. So what you can do this groundwater management aspects, because groundwater is subsurface. We cannot do direct, we cannot go do the remediation or something like that. So what are those preventive techniques and what are those remediation techniques that are available? We have to think of seriously, and we have to implement those aspects. And this another aspect that I have discussed about these anthropogenic factors, we have to understand very carefully, and we have to implement it in our groundwater policy. That must be included, and that should be the key factor to maintain the security of our groundwater. For example, if you can do artificial recharge, some of those places which the groundwater, the level is drastically declining, or something if you can think of by without depending too much on groundwater, if you can do this rainwater harvesting. And another important thing, the wastewater is one of the major means that is being released. But if the wastewater that cannot be waste, if we consider that wastewater as a resource, and if you can treat this wastewater and recycle, that can even manage in a lot of ways, rather than depending too much on groundwater for all these purposes. So these are the certain aspects we have to act, and we have to take this initiative. And also by doing individual, it's even not possible. It's a combined effort, and also our government, they should take certain initiative. Whatever our water policy, some of those things must be included in the water policy. So that will really help you to augmenting this water resources. So this is all about my courses, and thank you everyone for listening. Hope this lecture quite helpful, and if you have any questions, let's discuss. Thank you everyone.
Thank you, sir. Yes, any participant, if you have any query, you can ask directly, or you can also write in the chat box. Dear participants, if you have any query, please ask.
Please ask. We can discuss a lot of things. Even I can even learn something from you, because it's an exchange thing. We can share ideas. If you learn something or some other things which are really relevant, we can even share our ideas or something. If you want to further discuss, you can email me. My email ID is pk.sahoo@cup.edu.in. Hello.
Hello.
Yes.
Sir, your voice is not clear. Please, will you write in the chat box?
So yes, it's a little bit difficult. It's not audible.
Hello.
Yes, sir.
Madam, I want to ask one question that
Sure.
80% or 80% is the groundwater for the drinking water. And what about the 20% which is remaining for drinking water? Drinking water as a source, groundwater is 80%.
Yes, yes. Generally, the dominating part, because we have see other thing drinking purpose. You heard about mineral water, because through this ion exchange, a lot of other process that water is being used. That is not whole 100% is not drinking water is not dependent on this groundwater. Even in the surface water, through this ion exchange mechanism, some other treatment by doing, they are filtrating and that is being used for this drinking purposes. But the dominant part, if you talk about this dominant part, the dominant part is coming from groundwater.
And in other 20% mineral water or maybe some
Surface water, mineral water. Yes, surface water is also is contributing.
what do you mean by surface water, sir?
Surface water means river water, river streams. So these are also, this water is being filtered through the ion exchange process and some of those filtration technique. Now you can see in the Punjab, the place where we are here. So here the dominating water is canal water. Canal water is being supplied, means all household. So what we do, we have this RO system. We just use this canal water, and the canal water get processed through this RO system, and that water even we are drinking.
Okay. Okay, sir.
Thank you.
Yes, any other query, please? If you have, you can ask directly. So one feedback from Dr. Shweta, that is, thank you so much, sir.
Thank you. Thank you. Thank you for your kind words. It's really, really important for me, because whatever we have discussed, if it is something gainful or it's something useful, that is really important for us. And we can even in further we can even discuss more, and if we can, this kind of lecture can be more benefit to the audience. Thank you very much.
Yes. Yes, any other query from any participant? So I suppose there is no query. So thank you so much, sir, for sparing your valuable time and sharing your best knowledge on this important topic with all of us. Thank you, sir.
Thank you so much for your invitation and giving an opportunity to speak on this platform. Thank you very much. Thank you.
Okay, sir. Thank you.
Thank you.
So thanks to all the participants for their patience hearing. And now is the time for lunch break, and we will again join at 2:15 p.m. As it is the validatory function of the 6-day online STTP. So it's humble request to all the participants, please join at 2:15 sharp. As the chief guest will among us around 2:30 p.m. So all must join before the visit of joining of our chief guest.
Madam, I have just a kind request.
Ji, sir.
So can I have a group photo, something like that? At least I can have with me. That means I have presented here or something. Can I have?
Yes, sir. Yes, sir. We can.
So that will be really helpful if you will be kind enough. So
all the participants, please switch on your camera. All the participants, please switch on your cameras.
So I don't know how to capture this picture. Can you, sir, take this picture?
No, sir, we will capture it for you, sir.
Okay. Then that will be great. Thank you. Thank
all
you.
the participants, please, you are requested to please switch on your camera. We need to take a screenshot of this session. Professor Huda Noreen ji, Manoj Kumar ji, Mukesh Kumar ji, Rajesh ji, please switch on your camera.